Good morning, everyone. My name is Rajesh, and today we will talk about autoscaling and elastic load balancer. Now, as you are aware, the function of these two, right? When we have instances running on multiple availability zones, and to ensure that we have, availability across the day 24 bar 7, even when some of the instances go down, this is something which comes in very handy. AWS does provide us options via autoscaling, wherein we can go ahead and you know um, set some rules wherein instances can be created when instances in one of the availability zone go down, or uh, probably because of the CPU utilization, the servers are overloaded and stuff like that. So we will talk about that in our demo session. Before we move on to the demo session, I quickly would want to walk you through in terms of the architecture. As you can see, we have our VPC which we have created over here. Then we will have two different availability zones, zone 1 and zone 2. We will also be configuring four different subnets, of which two would be public and two would be private. Then we will have one elastic load balancer which we will configure in the public subnet. As you can see, there is a small box with dotted lines, the black one. Now this is the auto scaling group. We will show you in the demo how we will configure this, but basically, yes, this will be the auto scaling group which will be used to to create our to auto create our instances, in fact, right? We'll be using something called as launch configuration for this. And yeah, last not but not the least, we also have the internet gateway via which the instances within our VPC will go ahead and communicate with the outside internet. And yeah, I think from architectural perspective, this is what we have. Um, what we'll be configuring in this demo is VPC, subnet, route tables. Then we'll go ahead and create elastic load balancer, auto scaling group. We will also touch base, uh, you know, uh, the Route 53 for domain configuration and health check perspective. All right. I think we are good to go. Let's quickly move on to the AWS console. So I have logged into my AWS console, and this is the region I logged into, North Virginia. So let's go ahead and quickly create a VPC. As you can see, there is already a default VPC. If you scroll towards right, there's something called as default VPC, which is yes. Yeah, just we just have to make sure that we do not tamper anything around this default VPC. If by mistake we end up deleting this, then there could be issues in terms of configuring our EC2 instances or stuff like that, and we cannot go ahead and create a default VPC. We'll have to call up the AWS support to have this reconfigured. All right, so let's move on. Let's go ahead and create a VPC. I will go ahead and name that as WordPress VPC. The reason, because we'll be hosting a WordPress site on those instances. We will talk more about that in the launch configuration 10.10.0.0/16. All right, so that's the IPv4 CIDR block which I'll be using. Okay, let me just go ahead and create an internet gateway. Okay, let me just delete this internet gateway. I think I did create that some time back. Okay, create internet gateway, IGW. All right, let me just go ahead and create subnets. Create subnet, PUBLIC, PNET, public subnet. Let me just put that into 1A zone. This is the VPC which I'll use, and one okay 10.1.1.0/24. All right, so um, just in case if we get some error message over here, see CIDR address is not within the CIDR address from VPC, right? So we just have to make sure that we are in the same range, right? Okay, let's go ahead and create the first subnet. Please note that, while I'm just naming this as a subnet or a public subnet, it's not really a public subnet right now. We will show you how we can go ahead and make those changes to actually make it as public. Let me just go ahead and create the second subnet. I'll name that as public subnet 1B. Okay, 1B. Okay, 10.10.3.0/24. All right, let me just go ahead and create another subnet. So we will call this as private. Okay, and we'll put that into this zone 1A again. 10.10.2.0/24. Let me just go ahead and create the last subnet. All right, I'll put that into zone 1B. Dot, I think that should be 4.0/24. Okay, I think we are done with the subnets SBNAT. Let me just search for these four different subnets. Now, as you can see, right, 1A, 1B, 1B, 1A. Let me just revalidate that in terms of availability zones. All right, so there are availability zones. If you see, there are 251 IPs available. Five in total, there'll be 256, but five are already reserved. So the allocation will happen only for 251. Mm, all right, default subnet, everything is no, so we are good. So as you can see, the route configuration on these, right, on these subnets is pretty much the same. There is no change as such. Now, um, unless we configure them with the right route table, these cannot be actually made public. So let me just go ahead and quickly create a route table, public route table, associate that with the VPC. I'll create that. Okay, I'll have to go ahead and edit the routes. Now, as you can see, there is already an existing route which is local, right? So what we have to do is we have to just go ahead and add, oops, 0.0. Let me just put an internet gateway. No results found. It's pretty strange. Internet gateway, no results found. Let me just see. Go to services, VPC. Internet gateway. Oops. All right. So as you can see, while I created the internet gateway, but I think I just missed out in attaching that with the VPC. I'll go ahead. I'll go back and internet gateway. I think we'll have to just go back and you know just refresh this 0.0. internet gateway. All right, here it comes. Click on save routes. All right, so now this is actually the public route table, right? Now, how do we make those subnets as public? We will have to go into the subnets association, edit subnet association. Now, as you can see, there are four different subnets, right? So just select the public ones, click on save. Fantastic. Now, the two subnets which we named as public subnet 1A and public subnet 1B, they are actually public subnet now, right? Uh, right. Let me just go ahead and see if I missed out something. Mm, let's go and click on the subnet. Okay, okay, fantastic. Let's go back to our architecture. We are done with the VPC Internet Gateway Public Subnet, right? Availability zone. Um, all right, so let's move on to the next steps. We will go ahead and create auto-scaling group and elastic load balancer, right? If we go to our EC2 management console, we will see, sorry, there is something called as auto scaling groups, and we have load balancers. As we talked about auto scaling groups, either you can go ahead and create the auto scaling group from here, or else we can use the launch configuration which we will be using for this demo session, right? Now if you see here, okay, let me just go ahead and delete this launch configuration. Okay, we'll go ahead and create a launch configuration. Before that, we just want to make sure that we go ahead and create a security group. Okay, we will be using the security group for the launch configuration. Security group, uh, launch configuration SG. Okay, VPC will be using this one. Or did I select it right? WordPress. Go ahead and create this. Okay, now I'll launch configuration inbound rules. I just want to make sure that we allow the HTTP. Okay, make it from anywhere. Save rule, and we will also add TCP for the time being. We can go ahead and remove that later. Custom TCP rule, port number 22. Anywhere, click on save. Now please note that the security groups, they are stateful, right? So what that means is whatever rule we apply for inbound, it gets replicated for outbound as well, right? So yeah, there are different material in terms of going through the stateful and stateless applications, so we will not cover that part. uh, let's go back to our EC2 configuration. Right, so let's go ahead and search for WordPress. Right, we'll select the T2 Micro, which is free tier available. WordPress, um, WordPress instance. Um, right, we do not want to configure anything over here. It's all pre-configured. Security group, select an existing security group. So launch config security group, we'll be using this. Review. All right, let me see if everything is fine. Security groups. Okay, launch config security group, fantastic. Create launch configuration, choose an existing pair, so that's fine. I'll go ahead and use the same one. All right, now the launch configuration is created. As I stated earlier, the auto scaling group, right? Either we could have created the auto scaling group from the EC2 management console or via the launch configuration. Once the launch configuration is complete, we can go ahead and create the ASG. All right, ASG. Group size, we would want to start with two different instances. We'll put that into our WordPress VPC, and as we discussed earlier, from architectural point of view, the auto scaling group is something that we will host in the private subnet. Right, these are two different private subnets. Next, configure scaling policies. Right, so scale between 2 and 4 instances. Uh, Let me just put some triggers over here. New alarm. So anytime we have the CPU utilization going above, let's say 70%, we just want to make sure that the auto scaling is triggered, and yeah, we would just lower the seconds to warm up timer, which is going to be 120 seconds or 2 minutes. We also want to make sure that we create a scale in policy. So what that means is, while during the peak traffic hours, while to balance the load, the number of instances get increased. But during the off-peak hours, uh, while there might not be too much of utilization of those EC2 instances, those will get a build, right? So we do not want to be in that situation. So to ensure that during the off-peak hours, the instances which have very low utilization, those will be taken off, and that specific load will be distributed amongst the already running instances. All right, so let's keep that as 40%. So when the CPU utilization goes down below 40%, for let's say for 5 minutes, we just want to make sure that the auto scaling scale in a trigger is generated. Let's go ahead and configure tags. All right, ASG instance. Okay, create auto scaling group. All right, successful, going fine, all good. Okay, all right. I think we are good on this front as well. Now let's look at couple of things over here. Okay, let me just go ahead and create load balancer. I think we didn't do that. Define load balancer. Um, let's ensure that we go ahead and create another subnet for, sorry, another security group for our load balancer. ELB SG. All right, ELBSG again. We'll just go ahead and modify the rules again. HTTP, given that it's a WordPress site, anywhere, click on Save Rules. For the timing, we just want to make sure that uh, we put in the TCP as well. Custom TCP, where is that? All right, 22. Sorry. Okay, let me just go ahead and create the auto scaling group. Uh, Sorry, elastic load balancer. Okay, now, okay, now if you remember the elastic load balancer, we did create that into the public subnets. This is the place wherein we have to go ahead and select the two different subnets, right? So uh, try it public subnet, this one, and right. So we have selected two different public subnets because it's an internet-facing elastic load balancer. Click on next, assign security groups. Oops. and this is what I always do. I leave a space between the load balancer name. Right. Okay, so we did create an security group. Let me just go ahead and create the, select that specific security group for our elastic load balancer. Um, okay, security settings. It's fine. Configure health check. Right. Response timeout interval. I'll just minimize that. Just to make sure that we have the results coming out pretty fast. Okay, add EC2 instances. We'll go ahead and add these two EC2 instances. Um, all right. Now, if you remember initially when we launched our EC2 instances, we did not have anything running. Now, as soon as we created the auto scaling group, we mentioned how many desired instances we need, and we mentioned that as number as two. That's why you see that there are two instances which are up and running now while we have started creating the elastic load balancer, right? Um, okay, ELB WordPress review and create. Okay, fantastic. Now I think we are good. Shows auto service, so that's fine. It'll take some time while the system is up and running. All right, as you can see, the DNS name. So this is going to be the DNS name, um, which we'll be using for our route 53 configuration as of now. Okay, I don't think it'll be accessible. Okay, let me just go ahead and look into the EC2 dashboard as to what's happening. Do we have the instances up and running now? Okay, they are up and running. Okay, fair enough. Let me just go ahead and look at the inbound rules. Okay, still not accessible. All right, now as you can see, it's up and running now. Right, so we have the two EC2 instances are which are going good. So let me just now I'll go back to the domain name stuff, right? Now we have something called as GoDaddy. I'm sure everyone is aware about GoDaddy, where you can go and buy domains, right? So I have used a similar service from .tk. I just want to make sure that for the demo purposes, right, I go ahead and get a free subscription. So I do have a domain wherein it just talks about something called as Nifty 50 ta.tk. So I bought this domain for free. Let me just go ahead and show you a demo around how Route 53 configuration works, right? So from the history, I'll just go back to the Route 53, right? Let me just go ahead and delete the previous hosted zones. Okay, I think there was something which was configured earlier. Let me just go ahead and delete this. Okay, fair enough. Now, from the dashboard, you will this is the home page that you'll get, right? So DNS management, click on Get Started Now, create hosted zone. Once you click on hosted zone, just put in and Nifty 50 ta.tk. Right, why did I put in that? Anyways, go ahead and create it. Okay, now as you can see, uh, we have created a hosted zone for our domain that we got it from .tk. So let me just copy this in a notepad. Okay, now if I go back to our my freenom.com, there is something called as name servers, right? Um, as you can see, I'll just go ahead and delete name servers. We just have to go ahead and update these name servers over here. It will tell the system that if someone is um, trying to access nifty50.tk, where the routing needs to exactly happen, right? So okay, change name servers. Oops. Let me just log back in my domains, manage domain, go to name servers. Okay, let me just go ahead and update it. All right. So what we had done is we have gone ahead and updated the name servers which we received from here, and we updated those into our in our management tools, right? This propagation will take some time, right? In the meanwhile, let's go through some of those uh, things that we did in our previous demo. Right, so we have the EC2 instances up and running. If you see, if I put in the DNS name for the Elastic Load Balancer over here, I get I go ahead and basically can explore the WordPress site, right? But obviously for the end user, right, we do not want to give this name, right? This is too cumbersome, and we do not want to expose the AWS domain name, right? So for the end user, it's going to be a simple name. That is something which you configured nifty50ta.tk, right? So let me see if it's up and running. No, it's not yet. All right, I think, yeah, we have to just go ahead and create a record set over here. Um, as you can see there, right? So um, for us to go ahead and access that, right? So we just have to create another record set. Alias would be a yes and a type category. We have to point that over to our ELP DNS name. Uh, let's make that as failover as well here itself. Evaluate target check. Right, I don't think I have created any specific health checks. So let me just go ahead and create a health check. So what is a health check? It basically talks about you know uh, um, checking if the domain a specific IP address or probably a DNS name is up and running, and based on the results, it says whether it's healthy or unhealthy, right? So let me just name this. eh, Okay, I'll configure that using the DNS endpoint. Oops. Uh, where is it? Elastic load balancer. I'll just copy this. I'll go back to our route 53. Click on next, create health check. It has been created successfully. All right. Uh, Try it. Let me just try and edit some of these parameters. I think I missed out updating those. Flow threshold 1. Save. All right. Now, as you can see, as soon as the after the 30 seconds, it did a health check, right? And it seems that it's up and running. It's fine. Edit health check. Do I have an option? Okay, I just want to show you something. All right. Yeah. So it's up and running now. As you can see, we are able to access over here from the AWS ELB domain name. We are able to access the WordPress site, but it will take some time for the propagation to happen, right? But let me just go ahead and see if it's working fine now. 50. Oops. Okay, still not yet done. Let me just go back to the hosted zones, see if everything is working fine. So while that is coming up, right, let me just do one thing. Let me just go ahead and, for demo purposes, right, I'll go ahead and delete these instances. Okay, I'll go ahead and terminate these. Right, so what is supposed to happen? As soon as we go ahead and delete or terminate these two instances, the auto scaling group will trigger. So what that will do is, it sees that there are no instances, and if you remember, we created auto scaling parameters, right? If we go back to our auto scaling groups, all right, so we mentioned that at any given point of time, I want two instances up and running, right? Um, it talked about, there were two instances which are already running. Minimum should be two, maximum should be four. It should be based on based on the incoming load, right? So we did all those checks and stuff, right? So let me just try and refresh this. As you can see, there are two instances which are still shutting down, right? Let me just refresh it again. See, the number has gone down to 1. Now there is only one instance which is running. Let me, okay, both the instances are terminated now. All right, so I think as soon as one of the instances was terminated initially, immediately the second instances, sorry, see, this one is up and running now. it is coming into production, right? Right. So let me just make couple of changes over here. Edit. Let me just make the desired capacity as 4, minimum to be 4, maximum to be 6, right? Let me also configure the load balance over here. Click on save, right? So we have made some basic configuration changes over here. So from the initial capacity of 2 EC2 instances, we have gone ahead and put in a request to have 4 EC2 instances running at any given point of time, right? If I go to my health checks now, right, you see it's unhealthy now, right? It will take another maybe 30 seconds to 45 seconds based on the traffic and how soon the systems are up and running to bring that into a healthy state, right? Because we have configured this with the with our ELB, and ELB is linked to the instances, so that will take some time in real world, right? While we have gone ahead and terminated those two instances in one shot, in real world, right, there is a very bleak possibility of something of that kind to happen. um, there is always a risk that things will go wrong, and that should be the underlying assumption for any infrastructure deployment, right? That things will go wrong. But the probability of that happening is very bleak in two different availability zones simultaneously. So if one AZ goes down, we will have the second AZ up and running, right? So the traffic gets diverted over there. And that's why we always mention that we need to have two instances up and running at any given point of time, right? So there is a there is an immediate failover to the second instance, right? Okay, it's still taking some time. Let me see. Yeah, it's status checks. It's still initializing. Let me just go ahead and go back to my load balancer instances. Okay, in service. See, we did create right. Yeah, I think it should be coming up any given point of time. So let me just see what are the different instance IDs: 10A, 920A, 638, 10A, 20A, 638. Yeah, these are the ones which are up and running. Fair enough. See, now the in service it has gone up. I think the fourth one is still coming up, right? Let me just try and access the okay the DNS name. I think should be fine now. Let me just go ahead and refresh the health check. Okay, still shows unhealthy. Let me see as to what's happening over here. Okay, we'll give another minute or so for this thing to come up. In the meanwhile, let me see as to what's happening on the propagation part. Okay, all right. Now, as you can see, right, Nifty 50 TA.tk, it's up and running. Now, remember, we did configure, in our route 53, how we can configure the ELB domain name, which is pointed over here in route 53 to to get the traffic diverted from nifty 50ta.tk. When an end user uses this user-friendly link, he will be directed to our ELB ELB domain name, DNS domain name, right? So um, yeah, I think Route 53 propagation is done as well. Um, I'm a bit surprised. Okay, it has come up healthy. I'm not too sure what was the reason why it took so much of time, while in the backend the instances were up and running and the DNS domain name was ELB DNS name was good as well, right? But anyways, so yeah, now that we have 4 instances up and running, let me just do one thing. Let me just go ahead and edit the instances again. Desired is 2, and I do not want more than 4, right? So as soon as we click on save, now we will have our notifications, you know, probably coming up over here. Let me just go back to the EC2 console. After 30 seconds, once the check is done, the auto scaling is triggered. Let me just refresh this again. I'll check grace period, default cooldown 120. It might take some time. See, now we see that there are two instances, right? As soon as the ASG got triggered, we have 2 additional instances which are going down. Now what that means is, from 2 different availability zones, one instance from each one has been terminated automatically because there is a trigger from auto scaling group, right? So yeah, because while we created ASG to have the CPU memory utilization when it goes above 80%, I do not have real traffic to kind of demonstrate that. But yeah, I just want to kind of show you guys in terms of how the ASG works. So if one of the system goes down, the second one comes up, and stuff like that. So let me see. Yeah, everything. So these, sorry, the 2 instances are terminated, and if I come here in my auto scaling group and the activity history, successful in terminating EC2 instances at this time around. All right. Okay. Yeah, I think we are good in terms of understanding um, elastic load balancer and how that functions in conjunction with the auto scaling group and launch configuration. Also, we did talk about the failover policy. Yeah, so if you just go ahead and look into the hosted zones, we talked about, um, you know, oops, yeah, so we did create one record which says that um, if there is a failover in the primary, they do the health check, and the traffic gets diverted to the to the second one, um, to the other availability zone, right? This was the target, the elastic load balancer, right? uh, okay, yeah, so we can go ahead and create couple of more record sets, right? Let's say if you want to use www dot for this one, um, we can always point it towards the elastic load balancer. I'm not sure if that will be the case. Okay, it works fine, right? Okay, yeah, from tutorial perspective, that's about it, guys, and thanks so much for watching this video. Thank you.